Professor V. Muralidhar is serving as head, Department of Mathematics, Mohammed Satak College of Arts and Science, Chennai. He has 23 years of teaching experience. He has attended 3 international and 5 national conferences. He was a resource person at the Mohammed Satak Teachers Training College in Chennai in 2012, where he spoke on History of Mathematical Genius Ramanujan. He was elected Academic Counselor, University of Madras during 2003-06. He has attended the Orientation and Refresher courses at the Academic Staff College, University of Madras. He specializes in stochastic modeling and has rich experience in discrete mathematics, operations research, statistical methods, and numerical analysis.
Welcome to UGC lecture series. In the last preceding sessions, we have seen different types of continuous distributions. So, under the continuous distributions, the first thing we have seen uniform distribution, and then we have seen some of the simple properties based on uniform distributions, and then problems based on uniform distribution. So, in this presentation, we will start with another important continuous distribution called normal distribution. Normal distribution generally we use in whenever there is large population, and especially when the population standard deviation is known. A normal distribution is defined as a continuous random variable whose PDF is, that is probability density function, is given by f of x is equal to 1 by sigma root 2 pi e power minus x minus mu whole square by 2 sigma square, where x and mu lies between minus infinity to plus infinity, that is over any real line. And now we will see some of the important properties of normal distribution. See, normal distribution is a bell shaped curve. So, it is symmetric about your mean. So, the central line indicates the mean of the distribution, that is x is equal to mu. On either side you have 2 extreme curves which will extend to plus infinity on the right side and minus infinity on the left side. We call them as tails of the normal curve, and this is called a bell shaped curve or normal curve. Another important property, it is we generally denote normal distribution by capital N of mu comma sigma, where mu and sigma they are nothing but parameter of the distribution. A parameter is characteristic of your distribution. So, for normal distributions the parameters are mu, which is mean of the distribution, and sigma, which is the standard deviation of the distribution. And in the case of normal distribution, unlike other cases, we have this distribution to be a symmetrical distribution in which all the 3 measures of central tendency, that is mean, median, mode 3 coincides. Third one, whenever you talk about normal distribution, some of the important properties about measures of dispersions are mean deviation about mean will be 4/5 of your sigma standard deviation. Similarly, quartile deviation is 2/3 of your standard deviation sigma, and standard deviation is going to be unity. Fourth property is the ratio of all the 3 deviations, quartile deviation, mean deviation, standard deviation, the ratio will take in this form, that is a 10:12:15. Another one is the point of inflection. Normal curve generally it will not touch the axis, it will go nearer to the axis. Hence, the point of inflection of the normal curve is given at x is equal to mu plus or minus sigma. So, mu plus sigma will be on the right side of the mean, and mu minus sigma will be on the left side of the mean. Another important characteristic is central moments. See, for the normal distribution, how we define the central moment? First one, we have odd central moments, another one is even central moments, and whenever you take odd central moments, we denote that by mu 2n plus 1 suffix, and odd central moment will be 0 for the case of normal distribution. The even moments are given by mu 2n, which is nothing but 1, 3, 5 etc. 2n minus 1 into sigma power 2n. This is the case for even order. And skewness, generally for any distribution, skewness denotes the shape of the corresponding curve. So, in the case of normal curve, your skewness is going to be 0. We have two types of measures here. One is moment coefficient of skewness, another one is Collier-Pearson's coefficient of skewness. Both these variations will be about the skewness will be always 0 for the case of normal distribution. Another one is kurtosis. Kurtosis is nothing but the highest peakedness of any distribution. So, for the case of normal distribution, your kurtosis is going to be highest peak, which determining the measure of skewness, that is measure of kurtosis. One is beta 2, another one is gamma 2. See, both these denote your kurtosis, one with respect to the moments, the other with respect to Collier-Pearson's skewness, and based on that moment coefficient of skewness, your beta 2 will be 3, and for your gamma 2 it is going to be 0 for the normal distribution. And ninth one, we have cumulative distribution function. See, generally when I say cumulative distribution, we denote by capital F of x. It is defined as probability that capital X less than or equal to small x. So, in this case, since it is a continuous distribution, your capital F x is defined as integral minus infinity to x f of x dx, where we denote f of x by probability density function. We in fact call this f of x as PDF if it satisfies the condition that the total probability is always 1. See, in the case of normal distribution also, your total probability is given by minus infinity to plus infinity f of x dx, which must be 1. And another important property of normal distribution is standard normal distribution. See, whenever you take a normal distribution, your mean and variance are the parameters, and it varies with respect to different types of large populations. So, for all this, to bring it to the under the neutral, we introduce the what is called standard normal distribution. Here we denote standard normal distribution by capital Z, which we define as x minus mu by sigma, and we call this as a standard normal distribution, where your mean must be 0 and variance is 1, and we denote this standard normal distribution by capital N with 0 comma 1 as the parameter. And how you compute this corresponding standard normal variate? See, to determine the standard normal variate, we make use of what is called standard normal table. So, any statistics book you can see on the back side standard normal table, where all the values are computed by using this formula. See, when I take phi of z, we call this as PDF for the standard normal variable, which we denote by 1 by root 2 pi e power minus z square by 2, where z lies over the real line minus infinity to plus infinity, and the probability that your x lies between x1 and x2, any two limits, are defined by integral x1 to x2 f of x dx. And if you see the standard normal curve, it is going to lies between the 2 points x1 and x2, that is from the origin. Hence, you can determine this integral by taking integral 0 to x2 f x dx minus integral 0 to x1 f x dx, where 0 to x2 will be greater than 0 to x1. So, that difference will give you integral between x1 and x2, and hence we call this first one where you denote by phi of z2, and second one we have got phi of z1. See, both these values are available in the standard normal distribution, where the methodology of seeing the standard normal table will be similar to as that you already seen your logarithmic tables. So, in the log tables also we have got your x value on the leftmost column, on the top right corner got different mean values. So, like that here also the standard normal table, on the left side of the table we have got all z value, on the right side you got corresponding percentages. See, depending on what value you have, you can determine that by using the standard normal table. That is why here this phi of z2, phi of z1, they denote the values of standard normal variable in the corresponding interval between 0 to x2, the other one is between 0 to x1, both you can see from the normal table, and simplify, you get the corresponding values of standard normal table. Another important property of normal distribution is area property. See, whenever you take normal distribution, you have area lies between the two values about mean and standard deviation. So, it is given by the following standard specification, that is 68% of the area of curve lies between mu minus alpha to mu plus alpha, and 95.44% area lies between mu minus 2 alpha to mu plus 2 alpha. Similarly, your 99.74% lies between mu minus 3 alpha to mu plus 3 alpha. So, this distribution is given in the adjacent diagram, which is very clearly represent the corresponding standard normal area. And another important characteristic is approximation to binomial distribution. See, if you consider the binomial distribution, where if the number of trial is sufficiently large. So, whenever I say large, that means the value must be greater than 30, and in this case your binomial distribution whose parameters are n and p, it gets approximated by normal distribution, which is denoted by capital N of mu comma sigma, where your mean of distribution is n into p and the variance is npq. Also, the discrete integer x in this binomial distribution b and p becomes the interval, that is x minus 0.5 to x plus 0.5 in the normal curve, that is n of mu comma sigma. Thus, we have probability function given by 1 by sigma root 2 pi integral x minus 0.5 to x plus 0.5 into e power minus half into x minus mu whole square by sigma square into d mu, and the probability that x lies between x1 and x2 is given by 1 divided by sigma into root 2 pi integral you take between x minus 0.5 to x plus 0.5 e power minus half into x minus mu by sigma the whole square and into du. So, this is how we define the corresponding probability function in this standard normal variable. Now, let us move to simple problems based on the normal distribution. So, whenever you are given any problem, first you have to convert the given data into the standard normal variable with respect to what mean and standard deviation given in the problem. Then you have to draw the curve corresponding to what value of interval is given. Then using the standard normal table, we used to compute the values and get the corresponding area. Now, let us move to simple problem based on normal distribution. First one, given a random variable x having normal distribution, that is mu is 18.2 and the standard deviation sigma is 1.25. The question is, find the probabilities that your x takes the value less than 16.5, greater than 18.8, between 16.5 to 18.8 and between 19.2 to 20.1. So, you have to determine these areas using the normal distribution. See, here in the first problem, since mean and sigma is given, you define z value corresponding to each x value. So, z is defined as x minus 18.2 by 1.25, that is your corresponding standard normal variable with respect to what x value is given in the problem. Now, first subdivision, probability that x is less than 16.5. So, this x you have to convert into z by writing this as probability of x minus mu by sigma, that I am calling as z, less than 16 minus 5 minus mu on the 18.2 by sigma 1.25. So, on simplifying you get your area to be less than minus 1.36. Now, you see the diagram as shown in the presentation, that is when I say z less than minus 1.36, that means you have to take area on the left side of the your curve, that is z is equal to minus 3.6. Since it is negative value, it falls on the left side of your origin. So, when I say z less than minus 1.36, you have to shade the area on the left side of z is equal to 1.36. I wanted to determine this area, but to find this area, we know that area less than 0 is 0.5, area greater than 0 is also 0.5, and in this case since z is less than minus 1.36, you can take z less than 0 minus area between minus 1.36 to 0, because on the left side of 0 your area is going to be 0.5 minus the area between the corresponding 0 on the left side is 0.5. So, 0.5 minus area between 0 and 1.36, you have to take this 1.36 in the standard normal table and give the value, the value corresponding to that is 0.4131. So, on subtracting, the required probability will be 0.0869, which will show very mild effect on the corresponding standard normal curve. And second one is you have to find probability that z greater than 0.48. So, here also when you say greater than 0.48, the curve is going to be on the right side of 0.48. Since 0.48 is positive value, it falls on the right side of your z is equal to 0, and greater than 0.48 means you have to shade the right portions of the 0.48. So, to calculate this value, on the right side of 0 minus area between 0 and 0.48. So, from this one can determine the area value. If you see the normal curve, the corresponding diagram to this is shown here. So, z 0.48 is on the right side of origin. So, greater than 0.48 means we need the area of this shaded region. So, you can determine this shaded region area by taking area on the right side of 0 minus area between 0 and 0.48. So, on the right side of 0 it is 0.5, and between 0 to 4.8 the area is take from the standard normal curve. So, the corresponding area to that is given by 0.1844. So, this we are getting from the standard normal table, and if you subtract from 0.5, the corresponding area will be 0.3156. Third subdivision, you have to determine the area between minus 1.36 to 0.48. So, in this case you can see the corresponding diagram is here. So, you have to find the area of the shaded region. This shaded region lies between minus 1.36 to 0.48. So, to determine this area, it is enough to take the sum of the area between minus 1.36 to 0 and 0 to 0.48. So, here I have taken area between 0 to 1.36 plus area between 0 to 0.48. If you see the normal table, for z 1.36 corresponding area value is 0.4131, and you take z to 0.48, the corresponding area value is 0.1844. So, if you add both these values, the corresponding area is given by 0.5975, which is the required area. Now, in the fourth subdivision, you have to determine that the x value lies between 19.2 to 20.1. For example, you see the problem here, fourth subdivision, you have to determine the value between 19.2 to 20.1. So, here for this case you have to first convert this x into z value. So, we are taking 19.2 minus mu by sigma. Mu is 18.2, sigma is 1.25. So, we are getting LHS 19.2 minus 18.2 by 1.25, that is 0.8. Similarly, on the right side 20.1 minus 18.2 by 1.25, and this area is we got this value to be 1.52. So, actually I need area between 0.8 and 1.52, and here the corresponding diagram is this. So, we need between 0.8 to 1.52. Since both values are positive, it is on the right side of z is equal to 0. So, to determine this area, you take the area between 0 and 1.52 minus area between 0 and 0.8. So, which can be determined from the standard normal table. That is why we got 0 to 1.52, area is 0.4357. Similarly, 0 to 0.8, the area value is 0.2881. So, on subtracting, we get the required value to be 0.1476. So, here we first converted x into z value, and then using the standard normal tables we have got area value taken, and hence we got the required area. Now, let us move to the another important problem, that is a sample of 100 dry battery cells tested to find the length of the life produced the following results, and here the results are mu is equal to 12 hours, standard deviation sigma is 3 hours. Assuming the data to be normally distributed, what percentage of battery cells are expected to have the life more than 15 hours, less than 6 hours, and between 10 and 14 hours. So, in this problem, if you see, the life of the battery cells is based upon how many hours it will last, and he has given the average life to be 12 hours and corresponding standard deviation is 3 hours, and hence first you will take the x, which is the length of life of dry battery cells. Now we wanted to find probability that your life period is more than 15 hours. So x greater than 15, convert this into z, you get x minus mu by sigma, which is greater than 15 minus 12 by 3. So probability that z greater than 1, that means you got z is equal to 1 to be this line which falls on the right side of z is equal to 0. When I say z greater than 1, you have to determine the area on the of this shaded portion as shown in the diagram. So to determine this area, you take area on the right side of 0, that is 0.5 minus area between 0 and 1. So on the right side of 0 is 0.5, between 0 and 1 you have to take corresponding area value, that is 0.3413, and subtracting we get 0.1587, and hence if you give in percentages we got 15.87% falls above the 15 hours. Now let us move to second subdivision, where I wanted to find the probability that your corresponding x is less than 6. So you convert similarity to z value, you get z less than 6 minus 12 by 3, which is going to be minus 2. So when I say less than minus 2, it is going to be on the left side of minus 2, which is the shaded region as shown in the diagram. On the left side of origin the value is 0.5 minus area between minus 2 and 0, you have to take from the normal table. So area between minus 2 to 0 is same as area between your 0 and plus 2. So because of the symmetry condition of the normal distribution, hence area between 0 and 2 is 0.4772. On subtracting from 0.5 we get 0.0228. If you convert into percentage you get 2.28%, which lies less than 6 hours. Next we will move to third subdivision, where I want to find x value between 10 and 14 hours. So convert into z, 10 minus 12 by 3, here 14 minus 12 by 3, we got a probability that your z lies between minus 0.67 to plus 6.67. See, if you see this area distribution, okay, between 0 to 0.67 and 0 to minus 0.67 both are got same area, hence we write this as 2 times area between 0 and 0.67, that is why we are getting 2 times 0 less than z less than 0.67, and this area is given by 0.2487 from the standard normal tables, and then you multiply by 2 you get 49.74%, which lies between 10 and 14 hours. Now let us move to another important problem, that is of a large group of men 5% are under 60 inches in height and 40% are between 60 and 65 inches. Assuming a normal distribution, find the mean height and standard deviation. See, in the preceding problems we are given the mean and standard value, we have determined the areas of the required x value, which we converted into z and determined the corresponding areas. Now in the second model we have got area value is given, that is 5% under 60 and 40% between 60 and 65. Using this data you have to calculate mean and standard deviation, which is going to be second type of problem in the normal distribution. So if you see the given data, he has given that 40% lies between 60 and 65 and below 60 you have got 5%. This is the data he has given, which is shown in the diagram. Now since the area lying to x left of x 60 is 0.05, convert this into z value. So 0 to 60 minus mu by sigma is going to be left side of 0, that is 0.5 minus area between 0 and 60, which is going to give you 0.45. So on subtracting you are going to get 0.05, and you have to see where this area lies in the corresponding standard normal tables. If you see that one, the corresponding z value you can determine, which is 1.645. So this 1.645, since it lies on the left side of the origin, we have minus 1.645. So this is your first equation in terms of mu and sigma, and in the second part he has also given that the height of 40% is between 60 and 65. So, when you write property, your x lies between 60 and 65, this is given to be 0.4, and if you take left side of x minus 65, we get the corresponding area to be 0.45, and you get into z value 65 minus mu by sigma, you get 0.5 minus 0.45. On the left side of origin, which is 0.5, minus area between 0 and 0.05, which is going to be 0.45. Hence, the value corresponding to this area is going to be 0.13, which is your z value, which you get by taking 0.05 in the standard normal tables. And if you take this equation, 65 minus mu by sigma equal to minus 0.13. Now, if you solve the equation 1 and 2, that is going to give you the mean and sigma value. So, these two equations you solve it, and if you subtract these two equations, say 1 minus 2, 1 minus 2 na 60 minus 65. So, it is minus 5 and mu will get cancelled, which is equal to 1.64530 minus 0.13 sigma. So, if you subtract, you get 1.515 sigma. From this standard deviation we got to be 6.33, and correspondingly we get mean to be equal to 65 minus mu equal to minus 0.13 into 3.3, and if you simplify this, your mu value will be 65.429. This will give you the mean of the corresponding distribution. Another important problem, there is another model of normal distribution. In a large institution, 2.28% of employees receive income below 4,500, 15.87% of employees receive income above 7,500 per month. Assuming the income follows normal distribution, find the mean and standard deviation of the distribution. This also belongs to the second model. So, he has given area below 4,500. See, in the normal curve you can see whenever x is 4,500, the value below that is given to be 2.28%. Similarly, above 7,500 is given to be 15.87%. First you convert this both into your standard normal curve. So, that is going to give you 4,500 minus mu by sigma, another one is 7,500 mu minus sigma, and both, since one lies on the left, the other on the right, we got to 4,500 minus mu by sigma equal to 2. Similarly, second equation you have 0.5 minus 0.1587. So, we get 0.3413, and correspondingly the area is going to be given by 7,500 minus mu by sigma, which is 1. Now, if you solve the equations 1 and 2, one can determine the value for mu minus sigma and mu plus sigma, which is 4,500 and 7,500. You substitute the values, you get sigma to be 1000 and mu to be 6,500. And let us move to simple exercise problems for your practice. First one, of a large group of men, 4% are under 60 inches in height, 40% are between 60 and 65 inches. Assuming normal distribution, find mean height and standard deviation. Mean height we must get 65.42, sigma 3.29. So, unlike preceding problem, here also he has given the area value, you have to find mean and standard deviation. In the second problem also same model, we have got mean 50, standard deviation 10, and in the last model you have to determine the probabilities that you have the values greater than 75.5, between 55.5 to 75.5, and finally you have got the answer for this problem to be 81 and 341. Let us have a small summary. In this session we have learned about normal distribution and the properties with simple applications and problems. Thank you.